had no idea. It was a complete surprise. I'm Maria Jasdambach, and I work at Leiden University Center for Infectious Diseases, and I won the Spinoza Prize. I got a telephone call from Marcel Levy, the president of the NWO, and when he started congratulating me, I thought, how's that possible? I haven't done anything. And then he told me that I won the Spinoza Prize, and that was wonderful. So as we know, such a prize is given to one person, but that's not really the case, right? It is for my group, for my team, for all my wonderful collaborators in Africa, in Indonesia. We've worked together for many, many years. So, you know, this is a real honor to have this prize, not just for me, but for many people in my department also. And I really would like you to hear what they do in the coming few minutes. They'll explain themselves what they do in the field.
My research is about parasites and how they influence our immune system. They can suppress the immune system for their own benefit, for their own survival. And at the same time, we actually see also some positive side effects. Because in those people having those parasitic infections, we see less allergic responses and less asthmatic responses. Yeah, what makes the work unique is that we have such unique facilities here at Lucid. In addition, what makes this place unique for doing the research is the fact that we have these long-standing collaborations with countries where we work together with people that have connections with the field where still these parasitic worms are endemic. And then we can study our research questions in collaboration with the local people.
My name is Meta Roesterberg and I lead a group of translational scientists, and we look into the development of vaccines for poverty-related diseases such as malaria, schistosomiasis, and basically investigating how we can translate preclinical concepts into the clinic and how we can quickly test them and then reflect back on how to improve them. Well, our work is unique in the sense that the studies that we do are technically complex. It requires translation from preclinical phases into clinical phases, so it's basically integrating a lot of different fields. It's highly interdisciplinary. And there's obviously a complex ethical framework around these early clinical studies, particularly if you purposefully infect people, which is also something that we work on and that we try to improve so that we have better frameworks and we know what the boundaries are within which we work. Yeah, I'm proud to say that we're world experts on this in this field.
In my research, we look at diagnostic tests, so to demonstrate whether people have a certain parasitic infection. And we do this via two different methods. Either a molecular procedure, where we look for DNA via a PCR, or we use antigen detection. And the interesting thing of these diagnostic tests is that we can show which people harbor a certain parasite, and we can also use these tools to monitor people. Besides research, I also spend a lot of time on teaching, and I find it really inspiring to teach young people about parasites, about how relevant parasites are, and what are the best ways to diagnose them. And beside the teaching in parasitology, I also do a lot on teaching in global health.
So I'm interested in the human immune response to infections and to vaccines. And one of the things I'm interested in is also co-infection. So if you're infected with a pathogen such as a parasite, how does this affect the immune response to either a vaccine or a secondary infection? And I think what really sets me apart is that I can study the immune responses at the mucosa. So most infections, they are at the site of at the mucosal sites and not in the blood. And what I do is I take these samples from the mucosa and then apply these tools to understand what's happening really at the site where these pathogens are.
So I'm working on diagnostics for schistosomiasis. Schistosomiasis is an enormous problem in sub-Saharan Africa, and to solve that problem we really need the tools. As I used to say, find it, then kill it. So we really need a diagnostics, and I'm developing, the most sensitive and specific, accurate diagnostics for schisto. Our unique combination of having both a strong network within the countries where they use it, as well as very strong laboratory facilities and connections in the diagnostic world, we are in the best position to make this test eventually available also in a commercial setting for those people who really need it.
So the world is growing obese, and there is more and more metabolic disease like type 2 diabetes. And these diseases are connected with an impairment of the immune system. And the parasites are actually mastering modulating the immune system. And so what we are doing is actually trying to understand how parasites or parasite molecules can actually modify the immune system and eventually improve the metabolic homeostasis. So at LUMC we have parasite life cycles, and so we can get unique access to some of these parasites or the molecules that are produced to this parasite, and they are used in the context of the research of my group to try to elucidate the mechanism by which immune system can crosstalk with metabolic organs and therefore modify the metabolic homeostasis and the sensitivity of insulin.
Parasites are well known to manipulate the immune system, and I'm interested in understanding whether they may also change the metabolism of immune cells to alter their function. So the field of immune metabolism is a rapidly developing and very exciting field, but there's very few that really study it in the context of parasitic infections, and that's what I'm really focusing on, and provides me a unique niche. And here at the LUMC I have the possibility to really study this by taking full advantage of the expertise and facilities that are available to study parasitology, immunology and metabolism.
My work mainly concerns glycobiology of host-parasite interactions. So we combine parasitology with the highly technology-driven glycobiology field. So we apply technologies like mass spectrometry and glycan microarrays to study these very complex organisms and the very complex interactions that they have with the host. And in that way we learn a lot about these complex systems, and we can apply these technologies and these innovative approaches that we're developing also to other fields, such as bacterial infections, viral infections, and beyond that basically any other disease. So I think this particular combination is what makes the work unique.
So here in Leiden I'm studying the malaria parasite, and I make genetically modified parasite to study the interaction of the host with the parasite. So doing that we can modify the parasite, and we found out that if we modify genetically the parasite we can create attenuated parasite. So these attenuated parasite, they are less virulent than the wild type parasite, so we can use them as a vaccine. And now we have a new vaccine, and it will be tested now in September. So of course the end of this year will be very, very exciting to see if we have an improved malaria vaccine.
First of all, we're a reference laboratory for parasitic diagnostics. So we receive patient samples from all over the country and even from abroad. We'd also like to facilitate good quality diagnostics for research projects, for example. And personally, I'm interested in parasitic infections in the migrant population. They can harbor infections, and not only they suffer from the infection, but also from the effects that parasites can have, for example, on the immune system. Well, my position in LUMC is unique in this field of clinical parasitology, which has an extensive history, already starting in the early days with a small laboratory for tropical infections. And it has extended now to a very broad field with fundamental studies, a lot of field studies and connections to endemic areas, as well as controlled human infections here in Leiden, which gives us a lot of opportunities. And it's great to be part of this team.
I was totally surprised to hear about the Spinoza Prize.
I was a bit surprised, but positively surprised, because the field of parasitology is very relevant.
On the other hand, I am surprised because it is a neglected disease. It's also a neglected type of infection generally.
Parasitology has a big impact on various fields, not just parasitology itself and combating worldwide parasitic diseases.
Parasitology has contributed so much to the better understanding of immune system.
For cancer, for vaccinations, infections, autoimmunity, and understanding how these parasites have co-evolved to shape the immune system, how they do this exactly. I think this will have very huge implications for all these fields.
Malaria is still very important. Every 2 minutes of my talk, one child is dying from malaria, so that's a crucial thing to try to fight for.
Obviously, I'm not very surprised that Maria Jasnambach has won the Spinoza Prize. She's famous for her work in immunoparasitology.
It's a clear recognition of the work that has been done in this field.
In our case, it's really the jewel on the crown of a lot of work that have been performed with the whole team within parasitology, headed by the fantastic lady Maria Jasnambach, who really brought us all together and inspired us to bring us to this great research.